Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another computer science lecture 9618 for AS level, and we were discussing section 8.1 database concepts, and this is the second part for 8.1. Next we have entity relationship diagram, or an ERD. An ER model or entity relationship diagram is based on a perception of a real world that consists of collection of basic objects called entities and relationship among those objects. The ER diagram is used to represent database schema. In ER diagram, a rectangle represents an entity set, an ellipse represents an attribute or a field or a column, however you want to call it. A diamond represents a relationship. Lines represent a linking of attributes to entity sets and of entity sets to relationship sets. These three are the basic shapes that you should remember about ER diagrams. This is the rectangle is an entity set, the attributes are ellipses, and the relationships are rectangular. Crow's foot notations are used to show relationship cardinality or type in an ERD. Dash means only one. This dash means just one. A dash and a ring means minimum 0, maximum 1. Dash and dash means minimum 1 and maximum 1 relation can be there. A simple crow's foot means many relationships. A ring and crow's foot means minimum of 0 and maximum of many. Dash and crow's foot means minimum one-to-one relationship, maximum many relationships. Example, one student will occupy one seat only, so between the entity student and seat we are going to have just a one-to-one relationship with double dashes, which means that minimum 1 and maximum 1 student can occupy a minimum of 1 and maximum of 1 seats. Then we have the second example where we have a lecturer and we have a courses. Now one lecturer can teach multiple courses, but for every course there must be one and only one, not less than one, neither more than one lecturers. One teacher can teach more than one courses, but any given course will have only one teacher at a time. Example 3, multiple students can be enrolled in multiple courses, so both of them would be have a many-to-many relationship, with it being 0 to many sort of scenario. Then we have the normalization process. Normalization is a database design technique that reduces data duplication or redundancy, enhances data integrity, and eliminates undesirable characteristics like insertion, update, and deletion anomalies. Normalization divides larger tables into smaller tables and then link them together using relationships. The purpose of normalization is to eliminate a redundant or repetitive data and to ensure the data is stored in a logical manner. There are three types of normalization in our syllabus. In the real world we have more types of normalizations, but in our syllabus for AS level we just have three. The first normal form, or the 1NF, the second normal form, or the 2NF, and the third normal form, and the 3NF. First of all, we are going to discuss the first normal form, or the 1NF. These three normalization forms are important because the examiner would give you a table, a database table, and ask you why it is not in a normal form, or what form it is currently in, and how you can make it into a second or third normal form. Alright. For a table to be in the first normal form, it must meet the following criteria. A single cell must not hold more than one value. This is known as the atomicity of the cell. You can also write this as all the fields should be atomic. That also means the same thing. There must be a primary key in every table or every tuple. No duplicated rows or columns are allowed. Each column must have only one value for each row in the table. This is another way for writing this point. The second normal form 2NF. The 1NF only eliminates repeating groups, not redundancy. Thus, there is 2NF for that. A table is said to be in 2NF if it meets the following criteria. It is already in 1NF. It has no partial dependency. All non-key attributes are fully dependent on a primary key. Now, what exactly is partial dependency? If a table has a composite primary key, which basically means if a table contains candidate keys or alternative keys or secondary keys or keys, basically it means if a table has two or more than two fields which are atomic or which are unique, and obviously out of them one you'll designate as the primary key, then all the fields besides the primary key fields in the table should depend on the entire primary key and not on a part of it. Basically it means the non-primary key attributes should not depend only on one of the candidate keys, but they should rather be dependent on all the possible primary keys or all the candidate keys. If any non-key fields depend on only a part of the primary key, a single field, it is known as partial dependency in the table. For example, here are three tables: the student table having student ID, student name and branch. Then we have a subject table with subject ID and subject name. Then we have the score table which has student ID, subject ID, marks and teacher name. Now over here, marks of a student are dependent on both primary keys, the student ID as well as the subject ID. However, the teacher name only depends upon the subject ID but not on student ID. This means we have a partial dependency in this table. As you can see, this is not the case over here. Student name is dependent upon student ID as well as branch is dependent on student ID. Then we have subject name is dependent upon subject ID, but over here we have a partial dependency. So in order to make these tables in 2NF form, we will have to remove this teacher name field to somewhere else. Then we have the third normal form, or the 3NF. When a table is in 2NF, it eliminates repeating groups and redundancy but not transitive partial dependency. This means a non-primary attribute or an attribute that is not a part of the candidate's key is dependent on another non-prime attribute or non-primary key attribute. This is what the third normal form eliminates. For a table to be in 3NF, it must already be in 2NF and it should have no transitive dependency or non-key dependency. So transitive dependency occurs when a field that is not the primary key is dependent upon another non-primary key field. For example, if a score table would include exam type and total marks for the purpose of calculating percentage, then it would look something like this. Now over here, exam type depends upon both student ID and subject ID, but the total marks is only dependent upon the exam type, which is a non-key attribute. Thus this means we have a transitive dependency over here. In order to make your table in 3NF, we will have to eliminate this. Here's a solved example of how you can convert a given table into 1NF, 2NF and then 3NF. Imagine a restaurant management application which needs to store data about the company's employees, having the following table of employees. We have an Alice who is a chef as well as a waiter. The state code of Alice is 26 and the home state is Michigan. Then we have Bob, who's a waiter as well as a bartender. Then the state code for Bob is 56 and home state is Wyoming. Then we have another Alice who's a chef. Her state code is 56 and she's also from Wyoming, or the home state is also Wyoming. So if this table is given to you, to convert it into 1NF, first of all you will need to introduce a primary key, and all cells should contain atomic values, or all cells should be atomic, or all cells should contain a single value only. So we can do it like this: employee ID, that can be our primary key. Then we would write name, then we would write job code. Now why we have created this field by the name of job codes? Because this field job contains multiple entries. Then we write the job, that J01 is a chef, 02 is a waiter, 03 is a bartender, etc. Then we write the state code and the home state from this table. However, doing so has expanded the table with redundancies. As you can see, employee ID 1, 1, 2, 2, 3, then Alice, 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 Bob, Bob, J01, J02, J02, J01, duplication, chef, waiter, waiter, chef, duplication, 26, 26, 56, 56, Wyoming, 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 Michigan, Michigan. As you can see, now there are a lot of redundancies in the table. As now 3 tuples with 4 attributes have expanded into 5 tuples with 6 attributes, as well as employee ID field, which is supposed to be our primary key, is full of repeating values. That should not be the case for a primary key. So next we are going to convert this into the 2NF or the second normal form, and for doing that we have to remove partial dependencies. Name, state code and home state are dependent upon employee ID. Employee ID, name, state code and home state. All three are relevant to employee ID, but job code and job are not. Or rather you can say that these things are dependent upon employee ID but not the job code or the job. Hence these should be moved to a separate table. Now we should break this one table into two, and we should call it as employee jobs and employees table. So employees table would contain employee ID, name, state code and home state. All of these three are dependent upon the primary key, and the job code and the employee ID are moved to a separate table. Employee ID is placed over here so it can be linked to the employees table using relationships. Then the third table would be the jobs table, where the job code and the job description or job name would be given. Next, eliminate transitive dependencies to convert table in 3NF. Now non-primary key attributes should not be dependent upon other non-primary key attributes. Can you spot where they are present? See, in the employees table, home state is still dependent upon state code, which is a non-primary attribute or non-key attribute. Hence it should be separated in a further table. So now finally, after the 3NF, our tables would look something like this: the employees job table, then the employees table with 3 attributes, the jobs table and the states table. The database has finally achieved third normalization form. State code would be linked to this, employee ID would be linked to this, job code would be linked to this. This is how all 4 of the tables would be linked together. And we have finally reached the end of our section 8.1. We have discussed everything that you need to know. I hope you have understood everything. If you have any questions or any confusions, then just write them in the comments below. I'll definitely get back to you with a proper response. I'll try to explain them to you again with a different angle. Anyways, if you haven't subscribed to my channel already, please do so and share it with your friends as well. Also, if you want to get hard copy of these notes or a complete study pack for AS, including topical past papers, as well as if you need the study pack for computer science O levels, the new syllabus, as well as if you need, or if you know anyone who needs study notes for physics, IGCSE or O levels, then you can use the form link that is given below in the description. I'll see you guys in the next lecture, and we'll continue section 8. We'll start 8.2 in our next video. So till then, stay tuned, take care, Allah Hafiz.